Exercise 2, self-evaluation, page 133. Yep. Consider the system Ij and the system Oj. The two vectors u is equal to I plus j, and v, that is I minus j. Right. Part 1. Show that u and v is a basis of the plane. Required to prove that u, v form a base of the plane. Is a basis مش طالع بالريح. خلاص اوكي. طب لا بكتب ولا بكتب is a basis of the plane. Right. How can we prove that two vectors uv form a base of the plane? Right. امتى I و j form a base? Can we say, for example, if you have these two vectors I, j, do they form a base of the plane? Yes? No answer?
It is which number?
Exercise 2, self-evaluation, page 133. I and j form a base of the plane, in which case طيب ننتبه شوي. When I used to draw a system I, j, how do I draw the lines d and d prime? How do I draw the lines d and d prime? No answer? Yes? Okay. For the solution. In fact, here, I and j form a basis of the plane, or as a basis of the plane, in case I and j are two vectors having different directions. If they have the same direction, and if the lines d and d prime are parallel, ما في يعمل base للplane. In this case, I is equal, if d and d prime are parallel, here you have vector I and vector j. But in this case, so I is equal to some constant times j, ماش إلى طعم. And then a vector, for example, here you have a vector u, then you can't write u in terms of I and j. Then once you wrote it in terms of I, then you wrote it in terms of j, because u and j have same direction. So you, I and j should not have the same direction in order to form a base. Here I asked, how do I draw the lines d and d prime? I usually draw it intersecting lines. They intersect at O. Or we said D and D prime, two lines intersect at O. O is the origin. صح? When you say origin, the intersection, O is the point of intersection. طيب if they are not, if the lines are parallel, where is the origin? ما في. No intersection. كل اللي كنت عم بحكيه هون مالوش طعم. So here D and D prime should not be parallel, should be intersecting. It means I and J should not have same direction. I and J should not have same direction. Right. So here UV, U, it is I plus J, and V it is I minus J. You have to prove that in order to prove that U and V is a base of the plane, so you have to prove that U and V don't have the same direction. Don't forget that vector U has the coordinates 1, 1, and vector V has coordinates 1, negative 1. So prove that these two vectors don't have same direction. So x of u times y of v and x of v times y of u. Check that these two values are not equal. Here the values will be 1 times negative 1, which is negative 1. And x of v times y of u, it is 1 times 1, which is equal to 1. These two values are not equal. It means that u and v, they don't have same direction. It means that these two vectors form a basis of the plane. UV is a basis of the plane. Okay, any two vectors that are or that they don't have or of different directions form a basis of the plane. Okay, so U, V, here they form a base of the plane, the basis of the plane. Is that clear? Do you have any questions?
Is this should they be perpendicular?
If they are perpendicular, then here we have the special case, orthogonal system.
Yes.
Like كتبناهم مرة هون وين أول ما بلشنا الدرس نتذكر بس نشوف وين كتبناه هون. إيه هون عم بفوتوا ببعضهم هون. Sorry, just a moment. So in order to write the components of vector I in the system O, UV, it means that you have to write I and of course J as a linear combination of U and V. What do you mean by linear combination? It means that I is equal to some constant A times vector U plus some constant B times vector V. Okay, like replace U and V by their values. This means that I is equal to A times vector U, it is I plus J, and vector V, U, plus B, I minus J. Expand and simplify. Then I is equal to AI plus AJ plus BI minus BJ. That means that vector I is equal to, collect like terms, AI, BI. So it is A plus B times I plus vector J, A minus BJ. Okay. These two vectors are equal. That means here the components should, or the coefficients should be equal. So A plus B, the coefficient of I, should be equal to the coefficient of I here, which is 1. A plus B is equal to 1. And A minus B, the coefficient of J, should be equal to the coefficient of J here, which is 0. We don't have J. Now, you have this system, a plus b equal 1, a minus b equals 0. Here, you can use the calculator to solve it. You get a is equal to 1 over 2, b is equal to 1 over 2. It means that vector I is equal to replace 1 over 2 u plus 1 over 2 v. It means that vector I will have the coordinates 1 over 2, 1 over 2 in the system O, U, V. Is that clear? The idea, is it clear?
Yes, Ustaz.
Now what about vector V? Same way. Sorry, vector J. Similarly for J. Vector J, A vector U plus B vector V, of course, different values, different constants. I mean, if you want to use other constants, X, Y, كله ماشي ما بيأثر. The same idea, you will get J is equal to A I plus plus J plus B I minus J. Then vector J, exactly the same way as I did here. It is A plus B I plus A minus BJ. Then the system you will get coefficients of I, A plus B here, and 0 on the left side. So A plus B equals 0. And in this one, A minus B is equal to 1. Add. Then A will be equal to half and B will be equal to negative half. So vector J will have the components half, negative half in the system O, U, V. Okay, here we changed the system, the base. مش بس translation يعني unlike exercises 18 and 19. In exercise 18, 19, the same base ij يعني هذا x prime is equal to x plus a or x minus a, y prime is equal to y minus b. Here we have the same base. The same base is ij, but only we translate the origin. We changed only the origin, not more. No, we are changing the bases. This is the difference. نغير البيسز كله سوا. فاكيد الكوردينيتس راح يتغير، الكومبوننتس الفيكتورز كله راح يتغير. يعني نحن عندنا هون we have this. هذا vector I and vector J. I plus J will be here. هذا vector U. I minus J will be this vector. هذا negative J will be here. I plus negative J. This is vector V. Now we are considering this system O, U, V. Right. We are finding components of this vector in this system OUV or OUV. تغير كل شيء. مش مثل اللي كنا عم نشتغل من previous exercises انه والله بعدهم اي جي بس انه صرنا هون. انه هيدا اي وهيدا جي in this system. لا. البيسز كله تغير. Okay? Right. I'm going to add one more part. Let's say we have point. Okay. Part C, not written, I'm going to add it. Let's say you have point A of components 3, negative 2, and the system OIJ. Find coordinates of A and the system O شو اسمه UV. What do you have to do?
I have to use the rule. Now we have their coordinates from the previous part.
Okay, which rule? X prime is equal to X minus A. Yes?
Yes.
No? Look here. The rule you are talking about, if you have system OIJ and a new system O prime IJ, same basis but different origin. Here we use X prime is equal to X minus A, Y prime equal Y minus B. We have the same basis. We only translate the origin, not more. While in this one, no, we have a difference. The bases are changed. We have different bases. Here we have basis IJ, here we have another basis. But moreover, if you are going to apply the rule, X prime is equal to X minus A, we have the same origin. True. Yeah, X prime, A will be when AB can the coordinates of the new origin and the old system. We have the same origin. فأصلا أكيد مش ظابطة. طيب, to apply also the same idea as I did here. Yeah, in order to find the coordinates of point A in the system OUV, it means that you have to find OA, vector OA, as a linear combination of vectors U and V. Right? And for example, if you have OA is equal to 3U minus 5V, then point A will have coordinates 3, negative 5 in the system OUV. Right? So how to find now 3 and negative 5? This is the point. Right. Back to OA. OA, A has coordinates 3, negative 2 in the vector or in the base or in the system OIJ. That means that vector OA, write it in terms of I and J. What are the components of OA in terms of I and J? Or how to write OA in terms of I and J?
It's 3i and negative 2j.
3i minus 2j. Okay. Didn't we find I and J in terms of U and V from the previous part?
Yes.
Okay. Okay. So we have I, which is equal to 3 into I, it is half U plus half V. Minus 2, J, J is equal to half U minus half V. So it's equal to half vector U minus half vector V. That means that OA is equal to, expand and simplify. So you get 3 over 2U plus 3 over 2V minus 2 times 2, or so 2 times half, which is 1V of U minus negative, so plus 2 times half, you get plus V, which is equal to 3 over 2U minus U, you get 1 over 2U. 3 over 2v plus 1 over 1v, they get 5 over 2v. It means that components of A will be 1 over 2, 5 over 2 in the system O, U, V. Okay? Is that clear?
Yes.
Okay.